Hi. Like Becky said, my name is Olivia Jasper. I'm a regional water quality specialist with ODA covering the South Willamette and Mid-Coast regions. Today we're going to talk about the Willamette Mercury TMDL, which is the total maximum daily load, and how it affects and is affected by agriculture practices, and then ODA's implementation plan and kind of our role in that TMDL, because there's a lot of different factors and different partners that are covering different areas of this. Okay, so we'll go over kind of the background of how the TMDL was introduced. And then we'll talk about like mercury on ag lands, like I said, how it affects and is affected by agricultural practices. We'll talk about how ODA is implementing our strategies to mitigate this. And then the kind of things that we're tracking for our annual and 5-year reports, and then any next steps that we've determined are necessary. And then we'll have some time for question and discussions. So brief history. 2006, the Mercury TMDL was issued by the state waters on the 303D list that were recognized to have over the total maximum daily load amount of dissolved mercury in the water column. And in 2011, the standard to what we wanted to lower the amount of mercury in the water column was revised to better protect human health. And I'll talk about that a little bit later in a future slide. In 2012, a statewide lawsuit resulted in revising the deadline in 2019. So then in 2019, DEQ, Department of Environmental Quality, issued a new mercury TMDL with those revisions as per the lawsuit and revised timelines, et cetera. But EPA didn't like it. They didn't like the percentage that DEQ said they would need to reduce mercury to in the Willamette Basin. And so EPA reissued a final mercury TMDL in 2021. Basically, the DEQ TMDL was about 220 pages long, and the EPA reissued final mercury TMDL was 33 or so pages long. And what they did was, hey, everything DEQ said about why this, happened and what they think they should do about it, the science behind why it's harmful, what we should, kind of everything except for the amount to which they should reduce it. We agree with that. And it was basically a 33-page annex that was saying per basin, instead of what DEQ had written, was about 14% reduction. EPA said, nope, 88 to 97% reduction. And that was about their revision on that. So our TMDL targets are a 0.14 nanogram per liter of total mercury in the water column, and then in fish tissue samplings, 0.04 milligrams per kilogram methyl mercury. And this is tested by northern pike minnow because they're the most sensitive to bioaccumulation. And so the revision in 2012 was that this was originally determined that we wanted to reduce this to 0.3 milligrams per kilogram of methyl mercury for fish tissue. And it was reduced to 0.04 so that it could protect recreational fishing of eating 23 8-ounce servings of fish per month for the entirety of somebody's lifetime, and they would never accumulate so much methyl mercury that it would be fatal to them. And that was based on the average consumption rate of native fish species by the Native American populations in this region. So that's how that number was determined. Okay, so mercury reductions that are needed in water, not all of them are covered by ODA, and there's a bunch of sectors that are combined. So currently, I'm sorry if you can hear my cat meowing, he's just like hanging out. Can you come get him? I'm so sorry about that. Okay, so the current concentration is 1.2 nanograms per liter, with a TMDL target reduction of reducing it 2.14 nanograms per liter. And that results in an 88 to 96% reduction by subbasin, which I'll talk about a little bit more extensively later. And the reduction percentage is provided for each sector, excuse me. So agriculture has a certain amount of reduction, groundwater has a certain amount of reduction, atmospheric deposition to water has a certain amount of reduction, and so on. And this right here, just, can you see my pointer pointing on my my computer? Or am I
Yes,
just,
we can.
okay, I didn't know if I was like arbitrarily doing that. So agriculture, zoned agricultural areas can cover any type of vegetative ecosystem, including forest, shrub, developed areas of agriculture, barren, grassland, wetlands, and more. So basically, for practices on ag lands, ODA is the designated management area for agricultural activities on non-federal lands. That means that that's the only area that we can really develop strategies for and implement and regulate. And Oregon Department of Forestry is also in charge of their area. ODOT is also involved, Oregon Department of Transportation. So there are other designated management areas. The only thing we can really talk about, regulate, strategize, and report on is agricultural activities on non-federal lands. So where is this mercury coming from? Well, we know that the primary source is atmospheric deposition onto the land and water, and it's mostly from global sources. And that's what the TMDL says too, is that we know landowners can't control this. And that is explicitly stated in the TMDL. But the mercury that isn't deposited directly into the Willamette Basin and is instead deposited onto topsoil from global sources can be carried to the streams and tributaries of the Willamette by erosion and runoff. And this is something that landowners can reduce. And that's what we're trying to focus on. So mercury load reductions for agriculture, forest, and other lands is either 88 or 97% reduction, and it's different per subbasin. So these are mandated by EPA to be achieved by 2048, and there are interim targets written into the TMDL implementation plan. Just as an example, so here's Clackamas Ag Water Quality Management Area, and it's outlined in this teal. So in the TMDL is written that in the larger part of the management area, this sub-basin, for which this is the hydrologic unit code, they need to achieve an 88% reduction in total suspended mercury. But in this smaller area that is outlined in the orange, for which this is the hydrologic unit code, they need to achieve a 97% reduction. And so that's just to show you, like, it's outlined in the TMDL that each of these areas, and it's not arbitrary, but each of these areas, EPA asks either an 88% reduction or a 97% reduction, depending on which HUC you're in, hydrologic unit code, and which subbasin you're in. Okay, so then, well, monitoring for total suspended mercury is very extensive, expensive, and complicated. And so as a surrogate variable, we settled on total suspended solids. It's a lot easier and cheaper to monitor, and it needs an overall average of 75% reduction throughout the Willamette subbasin. And this is to be achieved by 2049 with interim targets. This 2048 and 2049 is not a typo. The writing of the TMDL just took so long that some of the timelines got bumped down the road by, like, 10 years from now, when they were writing it in 2018, we had this. And then when we adopted the TSS, so 10 years from now was writing in 2019. And so that's why if you do read the TMDL, you'll see this discrepancy in numbers. But the interim targets are really what matters. And then the implementation plans of the designated management areas as well. Okay, so the good news is that we already have practices and strategies on ag lands that we assess will help reduce mercury to the needed threshold. There's practices in the upland, so agricultural practices upland of the Willamette Basin, and then streamside area practices as well. So minimizing bare ground in winter by either planting cover crops or not, like basically strip harvesting and doing like no-till practices for harvesting, as well as the use of our soil health specialists within the SWCDs, within ODA and our other partners. They can advise best management practices for soil health that help with infiltration versus runoff. And so keeping the water on that property is really the goal. And then addressing erosion from roads and related structures. So areas can be zoned agricultural, but still have roads on them, and planting those vegetative buffers along the roads can really help reducing sediment, making it all the way into the Willamette. And then streamside areas, excluding livestock access to the streams. If anybody has questions about this, we can cover this later. And then establishing streamside vegetation to help filter pollution and stabilize banks. And so we achieve these strategies by basically, we have rules for them, and we can require landowners to be in compliance. And for the most part, landowners throughout the Willamette Basin and actually throughout Oregon are within compliance with our ag water quality area plan and rules. But we do have a regulatory backstop. So if somebody is blatantly out of compliance, we do have a regulatory backstop. Most of the time we can just tell them, hey, this is how we or the SWCD or NRCS can help you come into compliance, and this is what you need to do. So we have a streamside vegetation rule, and that basically says to site capability, vegetation needs to be allowed to establish for the purpose of filtering any sediment that may run off of the property and providing stream bank stability. We also have a waste rule that says that a landowner to the maximum reasonable degree is required to prevent sediment from reaching streams, either from runoff or being directly deposited into them. And then some management areas also have rules about erosion from farm roads. So for planning and reporting, DMAs, designated management agencies, were required to develop 5-year implementation plans. Since this was finally issued at the beginning of 2021, and we've kind of gone around that rigmarole of the public comment period, and it's been accepted, it will now start this year, the implementation plan 2023, and go through 2027. We're also required to develop strategies, milestones, and timelines, and provide annual and 5-year reports. And so ODA took that, and our approach to it was to link basin-wide planning and reporting to biennial review processes. So what that means is each ag water quality management area has a local advisory council, and every 2 years we go through a review of the ag water quality management area plan. And we've started including this TMDL language and strategies, milestones, timelines, and goals into the ag water quality management area plan, so that there's more buy-in from more partners, and we can understand, is that goal, is that timeline aligned with the other things that we said we plan to do in this management area. We're also linking strategies to the ag water quality monitoring strategy and leveraging existing program elements and data. This is a lot of kind of corporate lingo, but this means we have strategic implementation areas, focus areas. We have strategic implementation of our program that our partners that use those implementation strategies report against. So they give us this information already, and we're able to synthesize it into our annual TMDL reporting. And then we can use that reporting to identify and fill any information gaps or implementation gaps. And then our annual reporting is constantly being improved based on those. So we, like I said, each ag water quality management area within the Willamette Basin has a plan that we look over every 2 years. There are 10 management area plans and within the Willamette Basin TMDL area, and there are 11 soil and water conservation districts that have a hand in those plans. So the ag water quality program process is all about this is a very broad and generalized outline of our strategy. So by providing outreach assistance and funding, that can translate to on the ground practices, which are designed to improve land conditions, which are in turn improving water quality. And so we developed 14 strategies for the Mercury TMDL. The ones that are bold here are what I'll be covering in this presentation. So 3, 4, 6, and 7. Practices implemented, compliance cases, and biennial reviews. So strategies 3 and 4 are pretty much the same thing. It's collecting reporting information, but it's from 2 different reporting areas. So basically, there are dozens and dozens and dozens of NRCS practices that are known to improve the environmental quality of agricultural management practices. And you can see some of them listed here. This obviously is not an extensive list, but the ones that are listed here and color coded are what we have identified that will help keep total suspended mercury down in the Willamette Basin. And the thing that's been added to this that I don't have on this PowerPoint is there's another column that we're actually accounting for that says this practice. There's a column over here that says why it helps reduce mercury in the water. So for example, micro irrigation, sprinkler, irrigation management, that all keeps excess water from running off the property. So if you have irrigation management, then you have, you can use less water, then more, less water runs off the property. And so there's an explanation column that we're also accounting for. Fencing that keeps livestock out of the water, etc. And then the reason that we implemented that is that can be applied to any of the NRCS best management practices. And it can be extrapolated to use for other TMDLs because the ones that aren't listed here still help improve water quality, but not necessarily specifically mercury. So they could help with water temperature, but not mercury, for example. This is an example of practices implemented by ag water quality management area. So each column is an ag water quality management area within the Willamette Basin Mercury TMDL area. And then the final column is totals. And this is just with like one extra little step, which is preventing double counting. So like I said, strategies 3 and 4 are the same. It's counting practices implemented, but strategy 3 is taking that information from scope of work reporting. And that's what we get from the soil and water conservation districts. They report to us what type of activities they've been doing. And then strategy 4 is that same information, but coming from the NRCS Willamette Basin reports. And so this report is just removing that double counting. So if an SWCD does a practice, they tell us, we count it. And if it's in the NRCS practice report, we just don't double count it, is the best way that I can explain that. Okay, so strategy 6, compliance cases. We already do this. We ask that landowners be in compliance with the ag water quality management area plan and rules, and we go out and do site visits based on citizen reporting. But as a strategy for the Mercury TMDL, we pull an annual report for the ODI from the ODI compliance database, and the metrics that we track from it is the number of cases that are riparian or sediment, like riparian area vegetation or sediment related specifically, the outcome of those cases, which for the most part is, they were already in compliance, or hey, they quickly came into compliance because the landowners in this state are awesome. And then we also record the ODA response time. So the milestone that we associated with this strategy was 90% of cases achieve their response time goals. And we did undershoot that a little bit, I think by 4%. So we have like 86% of cases achieved response time goals. And so that's kind of what we're looking to improve in the next biennium. Okay, so strategy 7 is including Mercury language strategies, milestones, and timelines within the ag water quality area plans. So in January of last year, the Clackamas biennial review and local advisory committee meeting happened, and that was a great time for us to develop template language for all of these things listed. Excuse me. And so our next steps are, we want to kind of extrapolate this language, template language that was developed, and add Mercury language to the other 9 Willamette area plans. We have 2 coming up this spring, and 1 just went through a light biennial review. So there'll be, the next fall will be a full biennial review where we'll actually add more language and milestones into the actual plan. Submitting the 2020 and 2021 annual report. So the 2020 was just finalized and it's up for review before finally being submitted. And that was basically, it took a really long time to develop what data we wanted to collect, how to synthesize it, how did it make sense, or how do we make it meaningful, and then use the 2020 report as a training tactic for the newbies like me. And the 2021 is almost done. It'll be done in March, and then we'll move on to the 2022. And then submitting a 5-year plan by August of this year, which will include a matrix of those strategies that I showed you, but all 14 of them. And it'll basically say like why we think this will help reduce mercury, how we plan to implement it, and then a short narrative that kind of ties everything together, and then actually implementing those strategies. The last one to be developed is called the landowner toolbox, and that's just like any additional voluntary practices that we think will help landowners, or that landowners want to see. And an example of that is an idea that a couple of our partners have thrown around, that's like certificates or letters of appreciation for things that landowners do that we don't ask them to be in compliance. We don't provide them any funding for it, but just because they're good stewards of the land. We do have some landowners that planted riparian areas, and they have, they planted 30,000 trees in an area, and it's like a small forest that's protecting the entire watershed. So that's kind of in development, and those miscellaneous things would go in strategy 14, which is landowner toolbox. And then of course reporting on that as well. So I have some time for questions and discussion, I think, right? Yeah. Oh, I didn't take as long as I thought it would. So we have plenty of time for questions and discussion. And while we're doing that, this is the contact information for my manager, the program manager, and then myself and my role.